Today we are moving little bit advanced topics in our ERDs. Probably you may, if you can't understand, just let me know, right? So I'll try to explain as much as possible, and if you have any issues, let me know later on. I will happy to re-explain it. So let's go very slowly. Right. Now, when you model ER entities, or when you find out any problems to now, for example, if you go to the industry, definitely you need to you will get a kind of a problem. So any opportunity, okay, you need to design a kind of a database, right? So the first thing first, what we need to do is identifying the entity or the objects, right? Now the problem is these entities or the objects may have different meanings. It depends on which person that you have talked to. For example, if I ask a question, uh, for example, I may have object like a lecture, right? Now, if I want to design a database for the university, right? And if I come across an object like a lecture, so if I ask a question, what do you mean by the lecture? Is it in an inaugurating event that you attend each week via the online means? Or is it a 2-hour block in your timetable? Is that what you mean by the lecture? Is it a downloaded copy of the slides that I am presenting today? Is that meaning by the lecture, right? Or is it a collaborate ultra version of a 2-hour talk fest that I am doing? So is that what do you mean by the lecture? So likewise, you may have a different issues. So any different kind of problems when you're trying to clarify some objects in a particular industry, right? And also sometimes when you consider the lecture, is it identical the lecture that I runs in this week with another lecture? Because in some semesters, I tend to use, actually I tend to teach 2 lectures in the same time, right? Because we have a lot of students, so we group them into 2 groups or 3 groups. Sometimes I have to deliver 3 lectures during a 1 week, right? Um, so is it identical? Is it the same lecture that I have delivered across every session, or is it identical for last week lecture, etc., etc.? So so therefore different objects can have different meanings, right? So what I'm trying to tell here is we need to clarify the meaning of the object we are trying to model, because it will help us to avoid any confusion, because these models we are not only we use to construct the databases, but also we use these models to communicate with each other, right? Because if you think about a very big development team, right, it may consist of 30 or 40 developers. So we need to communicate. Maybe they may reside in somewhere else, some other country, right? How are we going to communicate it via the models, right? Sometimes we need to communicate with not only the developers, maybe project managers, other various stakeholders in the project, right? Sometimes the users, project sponsor, etc., etc. So to avoid the confusion, the meaning objects that we are trying to capture, the meanings that we are trying to inherit, them has to have a kind of a consistency, right? So that is what I'm trying to tell here, right? Sometimes same problem happens if I trying to clarify the class, right? Now, for example, if you think about a class, sometimes classes can be treated as a tutorials, right? Or it can be treated as a labs, right? For me, actually, for this subject, labs and tutorials doesn't make any sense because I use it interchangeably, right? Sometimes I call labs, sometimes I call tutorials. Sometimes tutorials and labs are 2 different things, right? Because we have tutorial questions and the lab questions, right? For us, it's not actually make any sense because it looks like the same thing. But if I ask that question, what is a class and what is a lab or what is a tutorial? If I ask that same question, these questions from someone in people and culture or human resource personnel, they may actually give a different answer because from their perspective, these things are quite different because why they are paying for tutors and lab demonstrators in a different pay rates, right? from their perspective, they will say, oh, no, classes are quite different to tutorial. Tutorials are quite different to probably the labs, and it might be quite different to the lectures, etc., etc. So it depends on which stakeholder you have. You may ask the question right now. That's really, really important because um, when I work in the industry, I had a lot of issues when I trying to clarify all these kind of phrases, words. So I remember, actually, I just put two stories here. One of the times I actually used to work in one of the companies where so I try to we, not me only, the kind of group of people, we try to design a kind of a warehouse program for that particular. There's a big warehouse. They are supplying the products to different clients, Coles, Woolies, Aldi, and not Aldi, and there is another retail. So they are supplying these kind of different products. So they use actually a lot of jargon words. When I actually go to these warehouse kind of environment first time, I face a lot of problem because they are using a lot of jargon words, phrases, they have different meanings. I am so confused. What do you mean by that, right? So they are talking about palettes, right? What do you mean by the palette, actually? Palette, because sometimes we need to actually have a kind of a capture that word and establish an object in our ERD. So sometimes I come, what do you mean by the palette? Is that something that with the boxes and we wrap everything, and then he said, what do you mean by the palette? Because sometimes and then the people are talking about street and aisles, right? Different people use a different words. The streets in these warehouse, we can move across. These are called the streets, and then you can see these pallets are stacked in these area, so we can move in. And then we have base and slots locations where we put those pallets. So they are using different jargon, different words. If I ask this question, what do you mean by the aisle and what do you mean by the street? Sometimes people will give different answers depending on whether you ask that question from the warehouse manager or warehouse person, or maybe somebody in the office space, right? And also the Americans and Australians, and they are using the different words, street, tiles. I think Australia, Aussies are using street, yeah, not tiles. Or sorry, aisles, not street. I think the Americans use the word streets. Yeah, so these, I mean, it took actually 3-4 weeks for me to correctly find out what do you mean by each of these meanings, right? And also they are talking about trucks and split trucks, right? Now what they used to do, they usually tend to transport all these pallets or the goods to different retailers like Coles and Woolies and other retailers, and they tend to actually send one truckloads of goods to one retail at a given time, right? So I am actually not so comfortable one time because when I try to capture that idea, right? Because I need to model it. So it looks like one truckload goes to one retail. It's like one-to-one relationship, right? One-to-one relationship between one truckload and a retailer, one-to-one. But one time when I trying to, do something with one of I think warehouse managers, he got a call from one of the truck drivers, and he said that the truck has been broken down. And then what happened? They tend to send another truck to take that goods, because in that truck actually has some goods with for the different retailers. It's a very not an emergency type of goods, but they have to distribute some goods to different retailers because they haven't actually told me that before. So it looks like it's not one-to-one in that time. So I then realized, okay, why they haven't told me, because it looks like one to many, right? One truckload goes to many retailers. It's not goes to one retailer. So then all of a sudden I need to come back to my model and then change all my ERD diagram because I haven't correctly captured that relationship or coordinate relationship, right? So likewise, you may face the same problem when you go to an industry. You need to really make sure, because you need to ask sometimes very dumb questions from the people. in order to clarify the stuff, right? Because sometimes they also don't know how to explain the stuff, right? So likewise, that is something that I actually like to tell you. Try to capture the real meaning of the object you are trying to model and the relationship. You need to be 100% sure before you create the table, because once you create the table based on the model, then that's it. Now you can't come back and then redo it. It's a very costly task. So yeah, so that's one of the hardest part in database design, the modeling part, because we need to be 100% sure that the models represent the true underpinnings of the transactions that the companies are dealing with. Right. So these are the things actually I like to tell you before we move in to our discussion. Right. So that's something that my experience. Okay. Right. Now remember that I think last couple of weeks, one of the weeks, I can't remember exactly, or maybe 3 weeks before, I have told you that the problem. I think I have discussed this problem, students and the enrollment issue, right? Remember, students are enrolling in the subjects, right? And I think I have shown you two tables like this. I'm not quite sure which week. We have the student table, and student table contains student ID, student names, and student addresses. And then we have the subjects, right? Subject codes, titles, and the descriptions. Now, students are enrolled in the subjects, right? So I have, now remember, I have created the model like this before, like, because students can enroll in many subjects, one subject can have many students. So therefore, many-to-many relationship mean we have a weak entity in the middle, right? Remember that I have discussed this before. So in the weak entity, we record the grade. Now I am actually telling you, this is very, this model has some limitations, right? Now, what is the primary key of the grade? By the way, what is the primary key of, sorry, what is the primary key of the enrollment? We need to grab the identifier from the student ID, and I need to grab the identifier from the subject. So the identifier or the primary key for the enrollment is the student ID and the subject code, right? So what are the limitations of this model? Because we have avoided the year and the semester details, right? Isn't it? So that is actually something that we haven't considered in this model, because it is very vital, right? Because the problem is, now here in this case, we are recording the grade a student actually obtained for a particular subject, right? So without recording the semester and year, so what will happen if a student fail one time and then he wanted to retake the test? What will happen? The existing grade will override, right? So that is not what we want. We need to actually keep the historical data, right? We can't override the existing information with the new information, right? So the year and the semester detail need to be included in some of the one of these entities, right? So that is what we have we need to overcome, right? So if you think about like this, okay, can I put the semester detail for the subject entity? Does it looks like a logical choose, but what will happen if I put now what in this case, what is the identifier for the subject? The identifier for the subject is the subject code, right? That is the primary key, right? So when I'm trying to put the year and the semester details in the subject entity, so what will happen is, now obviously then I need to actually take year, semester, and subject code, 3 columns as a composite identifier, right? Because each year, each semester, we are offering the same subject again and again, right? So that means in order to facilitate that reoccurrence, year, semester need to take it as a kind of part of the identifier. Then we have a problem, right? Then we have a problem. The main problem is why each time when the subject repeats, the title and the description has to repeat as well. Now see the description of the subject, right? Description of the subject is huge, right? Huge text. So what will happen if you repeat the same info again and again? it will lead to redundancy, right? Redundancy. Now remember, one of the major tasks or one of the major problem in having a better database is the redundancy, because if you have redundant information, it may probably lead to more anomalies in the databases, right? So that is something that we need to be careful about. So how are we going to avoid these redundancy? But still we need the year and the semester detail, right? So that means probably year and semester probably will not going to fit perfectly in the subject entity, right? So that is not the perfect place that we can fit these two pieces of information, right? So, so if we actually think about this more, this issue, right now, but this is a logical choice as well, because sometimes some may think, okay, why the year and the semester also related to subject? Why we put into another entity, right? So that is why we need to actually think about this. Now, when it comes to entity, the attributes in an entity can have, actually there are two types of attributes, right? Some contains more constant or more static or more fixed type of information, whereas other columns can contain more variable types of information. It keep changing, right? Variable means keep changing, right? Now, if you think about our subject entity in this case, subject codes, subject titles, subject descriptions, and objective, etc., etc., all these stuff will probably remain unchanged for quite a period of time, right? It looks like a fixed or static information, right? But if you think about other stuff like, okay, who is teaching this subject? Convener, right? So this semester one convener, next semester another convener, right? Conveners can be changed semester to semester, right? And the date of the exam, textbook, right, etc., etc. All these stuff will be changed semester to semester, okay? So you can see the attributes that belongs to a particular entity can have two types: static information and variable information. So now the thing is this. Now the thing that you need to consider, if you have the static and variable information, what you need to do is you need to actually split. You can't keep both of these information in the same entity, because if I keep both of these information in the same entity, redundancies can happen, right? Like in this case, right? So we have a static info like subject, code, description, and title, and also we have variable info like year and the semester, right? Because it can change. Year is changing, semester is changing. So what we need to do is we need to take that out, and then variable information we need to put into another a separate entity, right? So in this case, I have a entity called subject offering entity. So I just put all the variable info into the subject offering entity, right? So what is the identifier for the subject offering in this case? So definitely subject offering is a weak entity because it can't stand by itself. It needs to depend on the information or the primary key with the subject entity, right? So the entities, so subject offering entity primary keys, subject code, year, and the semester, right? Now we have split the information, fixed in one entity, variable in another entity, right? So both of these has its own identifier, right? So now we can have can put the test data and see how it works. So you can see INF10004. Now you can see INF10004 subject. In the subject entity may have many relationships with subject offering, because this subject can offer in multiple years, multiple semesters. So that is perfectly okay, right? And then each semester, each year, we may have different conveners and different exam dates, right? So that's perfectly okay. It's perfectly logical model, right? So now if you relate it to the other more information, like right now we have overcome redundancy issue. Right now you can see in this case, the subject entity now contains all the fixed information like subject code, title, and their description, right? So this remains as fixed, but the subject offering entity have all the variable information. You can see we offered this subject in 2022 semester 1, then 2023 semester 2, and then 2023 semester 1, etc., etc., with different conveners and different exam dates. Okay. Actually, here I need to, this is wrong, I think 2023, right? So I think I need to change this date. So it's my mistake. Exam dates are wrong. Okay. Yeah. So the enrollment issue that we have discussed before. Now, if you think about this problem, right, this particular model. So what we need to do is now we have created the subject offering entity. So the problem now the next issue is now if you think about the students, right? If you think about the students as you, so if I have another entity called the student entity, for which entity that entity is related with? Is it related with the subject entity, or is it related with the subject offering entity, right? So that is the next question that I like to actually raise in this case. For example, here you can see the student entity. So where is this? Where I can relate this one? What do you think? Can I relate it to the subject, or can I relate it to the student? Now think about in yourself, right? In yourself, you guys. Now this semester, this teaching period. What is this teaching period? This is teaching period 2 in 2020, right? Teaching period 2 2020, right? So you still enrolled in the subject, right? Yeah, INF10004. Are you enrolled in the subject directly, or are you enrolled in the subject offering? Right? That's my next question. Can you answer that question? Are you enrolled in the subject or subject offering? You are enrolled in subject offering, right? Subject offering, not the subject, right? Because you are enrolled in 2020 TP2 offering of INF10004, right? So when you're trying to establish the relationship, you need to always think about, are we establishing it with the static entity, or are we going to establishing it with the variable entity? So in this case, variable entity, right? Variable entity. So I can have now this kind of model, right? So students are enrolled in subject offering actually, right? Actually, one student can enroll in many subject offering because you are enrolled in 4 subjects, right? So many. And if you think about one subject offering, we may have many enrollments, so many students, right? So looks like there is a many-to-many relationship between the students and the enrollment, right? Student and the enrollment. So if you have many-to-many relationship, what will happen, right? What will happen? We need to get rid of this many-to-many relationship, right? So that is what we are doing, right? So if you get rid of many-to-many relationship, I definitely have a weak entity, right? So that weak entity is called the enrollment entity in this case, because students are enrolled in the subject of that, right? So this is where actually we record the grades, right? So students are enrolled in subject offering and they are obtaining this grade, right? So what is the identifier for the grade enrollment? Yeah, so we need to take the student ID, so that's underlined, and we need to take the identifier of the subject offering. What is the identifier of subject offering? Subject code, year, and the semester, right? So there are 4. So how many columns now we have in the enrollment? We have student ID, year, semester, subject code, plus the grade, right? So these are the columns. So now let us put some data and see how it works. Did we overcome the issue that we have faced before? I think so. Now in this case, you can see. Now what is the main problem in the earlier model, first model, earlier first model? Because this is our first model, right? Now what will happen each time the student retake the test or enroll, and then the grades will, what will happen, it's override, right? If now first time if we fail, then second time if we pass, then the fail will become pass, right? But now what will happen, we can definitely overcome that issue, because now we can record the historical information. For example, this student undertook INF10004 2022 semester 2 failed, and but 2023 semester 1 he retook the test, then he obtained distinction, right? um, so without having any issue, we can actually record the information. So that is the idea I need to tell you now in this case, right? Now see, this model is quite different to the model that we have discussed earlier, right? So this model, so it's quite different, right? So why it is quite different? The reason is we get rid of variable, and we separated variable information with the static information, right? So this is static, this is static, this is variable, and this is variable information, right? So same thing happens in any other scenarios, like you can apply the same concept to different scenarios, right? For example, if you think about, okay, we have say we have favorite bands, so they are having a kind of a different tours or different performances in different countries or different venues, right? So we can have a model like this. We have tour and tour offering. So and then we have different theatrical performance by, you know, the different performances, right? So we can have play and performance. So likewise, you can see kind of same relationship applies. Um, um, if you can apply the same kind of concept. But you need to be very cautious about this as well, because it will not actually apply for every single situation. Now if you think about this situation, right? So it says that we are having a meetings. Now we think about Swinburne have meetings. So in this case, they have saying that each meeting has a meeting ID, right? So you can't say, okay, meeting have meeting offerings, right? Because they have given meeting ID. So one meeting ID for each meeting, right? So in this case, there's one single occurrence for each meeting, because we have separate meeting IDs, right? So we can't have meeting offerings in this case, okay? You can ask question like, does this meeting have multiple offerings? No, right? Because no one meeting can offer we can only offer in a once, in a single date and a single time, because it has a single meeting ID, right? Sometimes they may actually tell, okay, without giving a meeting ID, they can say date and the time of the meeting, right? So if you have date and the time of the meeting, you can say, now in this case, they have given it. So if they haven't given the meeting ID, so you can say, okay, date and the time is the identifier. So in that case, we don't have a meeting offerings, okay? Because one date, one time, in a given date, given time, we have only one single meeting, right? Right, so that is something that I need to tell you. This is very important when you're trying to establish some kind of relationships. So remember to split the variable information with static information, all this. So don't mix it up in a single entity, because then you will face a lot of issues in redundancies, right? That's something that you need to think about. Having said that, okay, what we can do is, can we go through this exercise and then try to construct an entity relationship diagram, right? Okay, let's do it as a group. Okay, right now let's read this scenario. Okay, so what they ask us to do is draw an entity relationship diagram, but I'm not going to convert this ERD into the relational schema. You can do it later on. But let's read the scenario and try to create the ERD diagram based on it. Now remember to apply the variable and fixed concept that we just discussed. And so I'll give you 5 minutes actually to think. Now remember the steps, right? When you construct the ER diagrams, remember last week I have discussed, I think around 9 or 10 steps, right, that you can follow. So you don't need to follow the same step, but I actually, when I do my first database class, I tend to follow these steps because it's very easy. If you have more experience, of course, you can skip some of these steps and straight away design the ERD from the middle. That's okay, but something to keep. Okay, so I'll give you 5 minutes to think, and I'll give you 5 minutes to think, and then let's have a kind of a discussion. So what you can do is, now usually we use diagrams.net to design ERD diagram, but I'm not going to use it. Let's use some kind of program like Paint to have a sketch diagram to practice. So if you have the Paint program, can you try to draw a sketch ER diagram based on what we have learned now? And then we'll discuss the answer. I'll give you 5 minutes, okay? So I'll switch off my mic now. I'll give you 5 minutes, and then let's discuss and have a kind of a one completed diagram later on. Okay, I'll give you 5 minutes. All right, so how do you go with your model? Right, so what I will do here, I will do, I'll take snapshot of this model. Uh, so let me take the snapshot of this model, sorry, this scenario. Okay, now let's first thing first. So what we need to do is to highlight the important terms. Now remember the important terms we need to highlight according to the steps. So they are talking about Great Week Escapes. So they are running bus tours. So I just so looks like this is a noun. So I just underline this. They runs the bus tours to popular destinations, right? So they're talking about the bus tours, right? Popular destination. So I underline this, looks like a noun. So one example is a tour to is the Phillip Island, right? So this is an example, right? Example of a bus tour. It has a tour code of P01. Okay, so they're talking about tour codes, right? So I underline that. The name of the tour is the Phillip Island Penguin Parade. So right, so the name of the tour, so I just underline that looks like a noun. The approximate duration of the tour is 6 hours. So duration of the tour, right? So duration looks like another noun. So underline. The total distance of the tour is 240 kilometers. All right, so the distance looks like another important word. A tour is offered on many dates in a year. Dates offering on many dates, right? Offering on many dates. So right, so these are the important stuff according to these first 2 points. So let's move to the third point. GVE has many customers, right? So we are talking about customers. So now I underline that. Each customer has the customer number and the customer name, right? So looks like these are the descriptors of the customers, right? Looks like these are the attributes of customers, right? So I underline that. A customer makes a booking on the GVE tour event. Okay, so bookings, tour events, right? So I underline that. So what do you mean by the tour event is a tour that runs on a specific date. So they called it as a tour event. That is what they mean by that, right? So that is why they have placed that inside these brackets, tour events. So bookings, tour events, right? So they are talking about two things. And then it says GVE records W if the customer prefers a window seat, right? Okay, looks like they're talking about the seats, right? So they are recording the seat of each tours. So I just underline the seat. A booking is for one customer only, right? Each booking is one. What do you mean by that? So that means if a family has five members, each member treated as one single customer, right? So that is what they mean by that. So maybe I may underline that as well. Okay. GV has a list of bus drivers. Each bus driver has an ID and the name. Right, so they're talking about the bus driver, look like another noun. Okay, let's underline it. Each bus driver has an IDs and the names, right? So IDs and the names, right? So what do you mean by IDs and the names? They are descriptors of the bus drivers, right? Looks like these are the attributes of the bus driver. Okay. Each tour For each tour on a specific date, one bus driver is assigned, right? So each tour in a specific date, one bus driver is assigned. Okay. Right, so think about the tour example described above. Are there any static attributes? Are there any variable attributes? Right. So that is one first thing that we need to actually clarify. If you get a kind of this sort of description, when you're trying to find entities, and then we are trying to find the attributes, then we need to think about, okay, which attributes are fixed, and which attributes are static, fixed, and sorry, which attributes are variable. Right, now let's go through this again. Let's apply what we have learned as a step. Remember the first steps. Now let's think about, now we are talking about the great weak escape, GVE. Do we need actually entity to represent the GVE? That is my first question. Is do we need an entity to represent the GVE? Yes or no? I need your answers. So let me know. Do we need an entity for this? Yes or no? No. Why we said no? What is the reason why we don't need an entity for GVE? Because the reason is what? Reason is we have yes or no attributes. Yeah. So one is you are right. Yeah, we have only one instance. Yes, we have one instance, right? We are actually developing this particular database for the GVE, right? So we have only one instance. We don't need an entity to represent GVE actually, right? So there is no nothing. So we can ignore that. Okay. And they're talking about the bus tours, right? Right. Bus tour. What do you mean by the bus tour, right? Bus tour. And then if you read further down, you can see the bus tours has tour codes, right? For example, P01 or P02, P03, etc., etc. So bus tours looks like looks like what? This looks like a entity, right? This looks like an entity. Okay. This looks like entity. What kind of entity is that? What kind of entity? Is it a strong entity or is it a weak entity? That's something that we need to clarify. Is it a strong entity or is it a weak entity? Okay, it's a strong entity, right? It's a strong entity because the reason is each tour has a separate tour codes, right? So that means tour code is the primary key of bus tour. Okay, right? So now we have one clue, right? So what we can do is straight away what I will do, I use this pen. Okay, sorry, I use this one. So straight away what we can do, so sorry, bear with me, my writing is quite because I'm using mouse, it's a bit difficult, so I'll try my best. Okay, so we can have, actually I can use this, we can have one entity now. So bus tour. Okay, or we can call not the bus tour, maybe we can say tour, right? So tour, so that tour has one attribute. You already now capture that attribute tour code, right? So let me take that tour code. So tour code is the primary key, isn't it? So I underline. Okay, right. Right. So let's go back. And then they have given more and more information here regarding a particular tour. Name of the tour, duration of the tour, distance of the tour, right? What are these things? Name, duration, distance again are the attributes of the tour, right? Attributes of the tour, right? So very easy. Now what we can do is we can capture these three straight away, right? Name, duration, distance. So let us put that here. So name, duration, distance. So I just put this is tour name, let me put just letter D. So DUR, duration, right? So duration. This is duration, and this is distance. Okay, right. So this looks like a kind of attributes, right? Attributes of a tour. Right now, the last one. A tour is offered on many dates, right? So date. So we need to record the date, right? Date of the tour, right? Date of the tour. So date of the tour looks like, appear to like belongs to the tour, But again, you need to think about, can I record the tour date in the tour entity? If I record the tour date on the tour entity, we have the same problem. Remember, redundancy issue. Each time when you offer the tours again and again and again and again, right? All these need to be repeated, right? Redundancy. Okay. So that means we need to take out this date and put into another separate entity because it's variable, right? Tour date is a variable information. Distance will not going to change. Duration of the tour not going to change. If they take, if they, we need to assume that the tour will take the same route. Okay. So distance will not change. Duration is not changed. Name will not change. The tour code will not change. So looks like all these four fixed type of information. Okay, fixed type of information. But the only variable information is a tour date. So we'll take the tour date and then we need to make a week entity. Remember, in the week entity we record all variable information. Yeah. So I'll name this as let's say maybe we can say it as, actually they have given a kind of a name, isn't it? They call it as a tour event, right? Now remember, when you read the second point, they says customers make a booking on an for a GVE tour event, a tour that runs on a specific date, right? So they call this as a tour event, actually. Tour event, right? Tour event. So so I can record the date here, isn't it? So this is a tour date. Tour date. Right. So what is the relationship between the tour and tour date, tour event? So one tour can offer in multiple times, right? So one to many. One to many, right? So if I put straight away the cardinality constraint, has to be actually something like that, right? Tour code must appear in the tour event, right? So we can say here the relationship offers, right? In many dates. So what is the identifier for the tour event now? What is the identifier for the tour event? So if I need to know the which tour that going on a which date, I need to take the tour code, right, from this side to this side. Okay, right. So that means I need to underline the relationship, and then I need to underline the tour date, right? So the tour code plus tour date itself will form a perfect identifier, right? If you combine these two. So the primary key for this is tour code plus tour date, right? Right. Is it clear for you guys? Right? Tour code plus tour date is the identifier, right? So let me know if you don't, if it is not clear for you. Okay. Right. So we sorted out this part, right? All right. Now we can move into the rest. Let me make it small. Sorry. Right. The second part, GV has many customers. Each has a customer number and the name, right? Customers make booking for a big booking on for a GVE tour events, right? And they are talking about the customers, right? And then it says the customers has the customer number and the customer name. So customer is an entity, right? Customer is an entity. We need to capture it. Customer number and the name is names. They are attributes of the customers, right? Attributes of the customer. So let's capture that first. So they are talking about customers. So let's have an entity somewhere here. So this is my custom entity. And the attributes of the customer is customer number and customer number and the customer name. Right, so let me name this number, and sorry, this little, so let me actually delete this part. Okay, cost number and customer name. Okay, cost number, and second one is customer name. Okay, so let me put the customer name there. Right. So the identifier looks like the customer number, right? So it's obvious. So, all right. So we captured these two. Customer makes a booking on for a GVE tour events, right? Right. So customers make bookings. Now remember, customers are not booking in the tours; they are booking tour events or tour offerings. I know this is tour offering entity, right? One customer can have many tour offerings, right? They can book many tour offerings, so there is no restrictions, right? So one individual customer can make many tour offerings or booking for many tour offerings. So one tour offering can have many customer bookings, right? So it looks like there is a many-to-many relationship between tour event or tour offering and the customer, right? Many-to-many relationship. So if you have many-to-many relationship, what will happen? We need to have a weak entity in the middle, right? So let's make that weak entity straight away. Okay, let's make. Okay. So what is this weak entity actually now? What we are going to record it here? We are recording what? Bookings. Yeah. This is the bookings. So one tour event can have multiple bookings, so many, and one customer can have multiple bookings as well, so many. So one to many, right? Okay. Right. So let me put a kind of a relationship name. So customers as bookings, one customer. So let me put it often has. Okay. So now now we can say, okay, so what is the identifier for the booking? Now that is my next question is, what is the identifier for the booking, right? What is the identifier for the booking? So identifier for the booking is, how you going to determine the identifier for the booking? We need to know who is that customer is, right? So that means definitely I need to underline this customer number comes this side. And also I want to know which booking or which tour event this customer has been booked. So I need to take the identifier from this side to this side. So what is the identifier for the tour event? Tour code and the tour date, right? So both comes here. So the identifier for the booking is tour date, tour code plus customer number, right? Customer number. Right. So then they further says GVE records W if the customer prefers the window seat. Right. Seat details. Right. So what do you mean by the seat detail? Where are we going to record the seat details now? Is it in the tour event? Is it in the customer, or is it in the bookings? What do you think? Seat details goes to which entity? Seat details. Any idea, guys? Seat details. So customers booking tour events, and then we need to record the seat of that booking. Yeah, that's right. Yeah, it goes to bookings here, because one customer booking a tour event, we need to record which seat they have booked in, right? So seat details or seat number, whatever, the window seat or whatever, we record here, right? We record there. Okay. Right. So let's put the cardinality or participation, cardinality constraints. So let me put one more hash key here, because we must know which tour event they are talking about and which customer they are talking about. So mandatory relationship, right? Right. So we have recorded that. And it says one booking is for one customer only, right? One booking is for the one customer. What do you mean by that? So as I mentioned before, if my family has 5 members, each member treated here as a one customer, right? So right. So that's what we mean by this. That's we don't need to actually worry about that because it automatically can record it here, right? And then they are talking about bus drivers, right? They are talking about bus drivers, and each bus driver has an ID and the name. So looks like a bus driver looks like another entity, right? What kind of entity is that? A strong entity, because each bus driver has an IDs and the names. So let's model that. So let me make a bus driver here, right? So this is the bus driver entity. So bus driver entity, and let's record the attribute. So bus drivers has an ID and the names. So this is an ID and this is the name. So let me record that. Record so this is bus driver ID, bus driver ID, and then this is the bus driver. This is the name. So let's underline the bus driver ID, right? So bus driver ID is the the primary key, right? So now if I think about this, so how the right? So it says each tour on a specific date, one bus driver is assigned. What do you mean by that? So now we have to relate this entity with this model. So where are we going to relate it? Is it relate with the tour? Is it relate with the tour event? Is it relate with the bookings, or is it relate with the customer? What is your idea? Let me know. So which entity I need to relate this with, right? Any idea? What's your thought? So which yeah, so we had to belongs it to tour event, right? Tour event. Yeah. So bus drivers are assigned to the tour events, not the tours, right? Tour events, right? So one bus driver can assign to many tour events, right? There is no restrictions, right? So one to many, right? But if you think about one tour event must have one bus driver. Okay, so so this is optional. This is mandatory because one bus driver may assign to many tour events, right? But one bus driver, if they assign it, it must belongs to one bus driver, right? So so we can write so we can write the relationship here assigned. Right, my next question is, do I need to take the bus driver ID from this side to this side to make it the identifier for the tour? Do I need it? So Shinal, you have a problem also. What I got a question. What if we put the customer number to the tour event and make it as a part of the primary key? So do we really need the customer number for the tour event? Now that is a question we need to ask. Now remember, now if I put the customer number for the tour event, what will happen there if I put the customer number for the tour event? So tour code, tour date, so that means it's unnecessary, right? It's unnecessary because it doesn't make any sense, because we can have one tour event. That tour event can have multiple customers, right? So the multiple customers in each single tour event can be located under the bookings, right? Because the thing is this, yes, you can put that information there, but then the problem is if you put everything into a one entity, again it may create some issues in for example, okay, so if I have, okay, for example, if I have more details like, okay, each tour event have activities, right, so if I put the activities here, or maybe each tour event has a some kind of tour uh, leader, or whoever we appoint to lead the tour, right? So all these information, again, what will happen for each customer if I put the customer without having this redundancy? So this will, again and again will appear for each customer. So unnecessary, isn't it? So that is the one reason why we don't have this. Why we don't link this directly with this, but through these bookings, right? Chanel, did you get my point? Right? That's the reason. Because at this point we don't have any other information, but there can be in a point where we can put so many other attributes in the tour event, right? So this unnecessary repeating for each customer. So we don't need that to happen, right? For example, in this case, bus driver bus drive ID goes there as a foreign key, right? So if I don't have the bookings for each customer, this foreign key will repeat. It's unnecessary, right? So that's the one reason. Okay, right. My next question is, is it okay to underline this assigned in relationship? So that means I'm taking the bus drive ID to the tour event. Is it necessary? Is it necessary? No, right? We don't need that, because this identify tour code, tour date is a perfectly identify each tour event. So it's unnecessary for us to take this one to this side, right? So, and the other issue is, if I underline this and if I take the bus driver ID, so that means each time when I create the tour event, I need to know who is the bus driver is, right? So I don't want that to happen. It's like, now remember, I have discussed the same issue in one of my lectures. I can't remember the exact week. Remember when we trying to introduce a new subject, right? Sometimes we don't know who is the convener is, right? We don't know the convener, but we just introducing a new subject, right? Same problem happens here. I don't want to know who is the bus driver is when I introduce a new tour event or tour of mine, right? So for that reason, I don't need the bus driver ID from this side to this side. So therefore we don't need to underline this relationship. So likewise, you need to actually ask question: do I really need to take that? Even when you take it, does it create any future problems? So yeah, so these are the small issues you guys need to actually ask when you design the diagram. It's not straightforward. It's not straightforward. All right, so this is the final version for this plot, right? So now we have separated the static and the variable information. So this is static. So this is so this is static, and this is variable with respect to the tools, right? And also this is static, and this is variable. Okay, because each time the bookings, the seat can be different for each booking. And also this is static as well. Okay, so static, variable, and variable, right? Right. Do you understand that? So when you design your ERDs, you need to actually think about these concepts. Okay. All right. So so now it's easy to convert this into the relational schema. It's a piece of cake. Anybody can do it, right? But designing this is very difficult. right? This is the skills, guys, you need to practice, right? Right, at the time, this now at current, we have a lot of demand for very skillful database designers. This is, you can't, nobody can teach it. You need to practice it, right? I can give you the concepts, but when you apply these concepts to different scenarios, it's quite difficult, right? Same concept. Don't worry. We have studying a lot of what do you call design different patterns, right? Different patterns. So these patterns will exist in different industries. What you need to know is these patterns. So if you know the pattern, you can apply the same pattern for different contexts, right? All right. So this is what I'm trying to actually teach you in this class, in this semester. Patterns. All right. So this is about this. Right, now we are doing another narrative, but this time we don't need to. I'll go through it. Now think about this business narrative and the same concept. If we apply the same concept, we can actually construct the ERD diagram without having any patient. So let's go through this narrative. Now think about, now I am coming back to our subject enrollment scenario, but I have quite a few number of other information as well. So let's consider our university. We have a number of subjects. Each subject identified by the subject code, right? And it has a subject title. Each subject may be run by a semester for each year. Right now you can see these pieces of information variable, right? So static. So these are static, and these are the variable with respect to subject, right? So what we need to do is we need to separate, yeah. So each semester the subject may have new convener, right? Again, a variable, right? A student is identified by the student number, right? So these are the attributes of the student. So looks like more static. Student names, address, phone numbers are recorded as well. So looks like another static information with respect to the student. And students are enrolled for the subject in a particular year and the semester enrollment, right? So enrollment. So how to record the enrollment? So students are enrolling in a particular year and the semester. And the grade for each enrollment is recorded, right? So how are we going to treat the grade? Is it a static? No, it is a variable, right? So the grade. And then it says further, each semester, each subject may have number of assignments. Now they are talking about the assignments, right? Now, is it a static assignment? Is it static information? Right? That is what we need to actually clarify. Each assignment is identified by the assignment number, like ASS1, ASS2, ASS3, etc., etc. So that means each assignment has assignment code, right? And each assignment has a narrative and the due date, okay, right? So looks like there are some static information as well, okay, with respect to assignment. And each student is awarded a score for the attempt at the assignment, right? Assignments are attempted by the student, so we need to record their scores, okay? So score is another attribute that we need to actually capture. Right, now if I given this kind of a narrative, now my question is how to start, where to start it, right? So there is no firm rules to building good interrelationship diagram. Even if I have given you the steps, some students actually follow very slowly with the few entities. That's perfectly okay. And some students will follow what, the steps I have given earlier one by one. That's okay. It depends on your experience with the business problems. More the experience, generally is very faster we are building interrelationship diagram. It also depends on how many ERDs you have previously drawn, because that's the reason why I'm telling you, okay, draw these diagrams again and again. Don't look at the answers or don't look at the solution. Draw it by yourself. So more the ERDs you have drawn, more the generally you are more fast in designing ERDs, right? And also it sometimes depends on how many IT subjects that you have completed. So still you haven't started your degree, but more this IT subject, sometimes can think logically whether it can be implemented without having any issue, but you will get that experience later on. But my advice is you need to draw more ERDs. When I give you ERDs, when we practice it at the class, and even in the lectures like what we did today, just draw it again, right? Maybe another 2 or 3 days time you may forget, right? Then just do it by yourself without looking the answer. So yeah, so you need to go through few iterations before it comes. Even me, for me, when I design the ERDs, I need to go through few iterations rather than, I can't draw it first go. Okay. So mistakes is general. Usually we will take mistakes. That's perfectly okay. Nobody can actually draw ERDs at the first go. Make mistake. That's okay. Don't consider it as a disaster, right? So you're learning. That's you're learning by practice. Um, so actually, earlier I have asked people to use pencil and paper, but now we can use the digital tools like Paint or whatever the digital tools. So yeah. So the question is, where do we going to start it? How to start it? That particular problem. You can follow the steps that I have given to you before, or we can start by drawing what you feel is correct, right? Sometimes you can skip from 1 or 2 steps and maybe straight away design the half of your ERD in a first go if you are more experienced or more skillful, right? That's And then think about the patterns that you have encountered before. Um, Assignments, lab questions. Now we don't have examples this semester. So always think about the patterns you have encountered in our discussion. So these patterns can apply in your future problems as well. And then the other important thing is try to draw fewer entities rather than more entities. Even nowadays, even I have more experience, I just draw few entities because it will give me a kind of a confidence to build a ERD without having any bugs or any issues. Because sometimes what will happen if you draw more entities, sometimes we reluctant to remove some entities, right? Because that's the human nature. Once you draw it, you think, okay, why I get rid of that, right? So you think about like that. Even if the entity is wrong, sometimes it's very difficult to remove it, right? Yeah, so it sometimes stops us to think alternative ways of designing the ERDs. So fewer entities are much better rather than doing much more entities. And the other thing is sometimes actually very easy for my perspective. I feel very easy to draw many-to-many relationships first. Because it shows more fewer entities, give better big picture about what the model looks like, and the other point is it's actually easy to communicate with the others because it's easy to read in English, and it's easy to explain to someone else. For example, if you have like if you say the actors appear in the many movies, so you can say, okay, there's a many-to-many relationship between the movie and the actor, right? But if you put the casting entity straight away in the between, remember the casting entity, weak entity we have created, and it reads very miserable, right? You can read it like this: an actor may have many casting. A casting is for one actor, and the other way around, a movie may have many casting and casting for one movie, right? Remember, when you read the relationship, when you read with both sides. So if you have created more and more weak entities, the relationship obviously will not actually give a meaningful picture. So it's very difficult to convey some kind of a logic to your users or even for the other developers. So better to start with many-to-many relationship, right? Right. So back to our narrative. Now this is the narrative that we just going through. So how we going to start it, right? They are talking about the subjects. They are going to be talking about the students. They're talking about their students are enrolling in the subjects, and each subjects have many assignments, right? Each assignment has different due dates and different narratives, and then students are taking the subject. We need to record the scores for each attempt, etc., etc. So how to start it? So sometimes some person can start it like this, right? First they will draw, okay, let's draw first student entity and then the subject entity. Yes, students are enrolled in the subjects, right? And then we assign these attributes to students and subjects, and then the leftover attributes, we can assign it to this relationship. Remember that what we have done last week. So in this case, year, semester, convener name, grades can be assigned to the relationship lines, right? Or sometimes you can actually, when you go through this narrative, you can straight away think about, okay, even when you think about subjects and the student, you can say that there are some subject attributes fixed, some subject attributes are variable. So therefore, rather creating this one first, I can create this one first, right? Right. So subject has subject offerings, and students are enrolled in the subject offerings, right? So this actually give you kind of a better picture, I believe, rather than going through this one, because you can see this has a kind of many meaningful kind of a relationship, right? Like what we did in earlier example in the tour, right? So tour offerings, and in this case, subject have subject offerings, right? And students are enrolled in the subjects. So same principle applies here. Customers are enrolled in, it's not enrolled, but customers are booking in tour events, right? So same can look like happening here, right? So I will actually encourage you to, rather than go to this one, even this is what what I have recommended to you. If I get a kind of this straight away, this will give you a little bit more details regarding the model you are going to create. So in this case, I will put all the year, semester, convening, exam dates for the subject offerings, because these are variable compared to this bunch of information which we attach to the subject, right? Subject, code, title, and description. So the identifier for the subject offering is subject code plus year plus the semester, right? So we need to underline this relationship. So that means we are grabbing this subject code from this side to this side. And then there is a many-to-many relationship between student and the subject offering, right? Because students are enrolled in many subject offerings, and one subject offering can have many students, right? So, and then they are talking about the assignments, right? Now, my next question is, now if I don't uh, expanded this issue, if I actually stick with this model, and if I try to put the assignment, now I have a problem, because the problem is I now have a kind of confusion. How are we going to assign this assignment? So you can see, is it logical to put that in? Actually, it looks like if I use this model, it looks like it's logical to actually relate it with the subject, because obviously subject have many assignments, right? And one assignment belong to one subject. So I may tend to actually assign this to the assignment. But is this the right way to do it, right? Because if you think about here, um, so you can, if you think about the subject code is going there as a primary key for the assignment. So the assignment primary key is the subject code and the assignment ID, right? But it looks like not logical as well, because each subject, uh, yes, so looks like now if I attach this assignment to the subject, what will happen, what it assumes is each subject has the same assignment each year, right? It's a static kind of thing, right? Uh, it's a static kind of thing. But if I actually use my previous model, later model, like student subject offering and subject this model, and if I think about how we're going to assign the assignment, now we can actually think about, okay, it's not actually belongs to the subject, it belongs to subject offering, right? It makes actually perfect sense, because each semester, each year, we have different types of assignments, right? So actually, its assignment is not belongs to the subject, but it belongs to the subject of it. So it makes more sense now, right? Isn't it? So you can see now. So what is the identifier for the assignment? So we need to take this identifier from the subject offering, that is my subject code, year and the semester, it comes there together with assignment ID, it will form a composite identifier, right? So now this is actually perfect logical solution compared to this one, right? So that is another thing that you need to remember, right? Sometimes we need to expand something before thinking, before we attach something else, right? Otherwise we will have this kind of situation, because here we haven't expanded this. So then we will attach something without thinking too much what will comes here, and right. So this is actually wrong in that case. So this is the right one. Okay. So likewise, you need to take some kind of decision sometimes. Can I expand something before I attach this entity, or can I attach this entity and then expand something else, right? So, so in this case, we need to expand the subject and subject offering, and then assign the assignment. And then they are talking about students are undertaking the assignments, right? Students are undertaking the assignment, and again we have the same issue, because you can see now here we have the many-to-many relationship. So can I link the student and assignment now and later expand this, or we expand this and then think how to relate the student and the assignment? For example, if you, okay, if I link this here, all right, it looks logical actually, because students are attempting the assignments, right? It says the students are attempting the assignment. So one student can attempt many assignments, and one assignment can attempted by many. So it looks logical, but there is a problem here. What is the problem here? What is the main problem here? Now think about yourself. Now you have enrolled in this subject, right? Therefore, you are attempting the database analysis and design assignment. So if you think about this model, it looks like any students who are in our database, or sorry, any students who are in our university can attempt any assignments of our database subject. That's not the case, right? I don't want to mark the other students' assignment, right? I want people who enroll in this subject undertake these assignment, and then I can mark this, right? So therefore, this link is actually not correct, right? This link actually tells you any student in the university can attempt um, um, any assignment, right? Any assignment, or any assignment of the subject offerings, okay? Or any offering assignment. So that is incorrect, right? So therefore, what we need to do is, first we need to expand this, right? Now what is this means? This means this shows you which students are enrolled in the which subjects, isn't it, right? And I want actually the people who are enrolled in the subject attempt the assignment, right? So this is the right, correct path actually. We expand the enrollment first, and then we relate the enrollment with the assignment, right? So there are one enrolled student can attempt many assignment. One assignment can attempted by many enrolled students. So that means, um, the uh, correct one is this, right? So now we have to have another. We need to expand this as well. So we need to have assignment attempt or something here, right? And then we can record their assignment grades in there. So this grade is the subject grade, and this grade we are going to record is the assignment grade. Okay. Right, so this is how we need to do, right? When you get a kind of a scenario, you need to think about like this, right? Always think about when to expand. Can I expand this before I attach something else? or can I expand it later and then attach this new entity to existing one, right? So it's very hard to practice. You need to practice it by yourself, right? Yeah, so there is no correct answer. Sometimes there's no correct way of doing the ERD. So you should think about yourself, right? So you need to learn, you need to uncover the problems, you need to cover relations, missing relationship, incorrect relationship. So you need to actually think about all these stuff before when you're drawing the ERD diagrams. Yeah, so that is the lesson I actually wanted to give you. So the final model now for this problem now looks like this, right? So we have grades for the subject, so that grade goes there for the enrollment, and also we have scores for each assignment attempt. That scores goes to the assignment attempt entity, peak entity, right? Um, Right. So, and then once you actually build these kind of model, you need to actually, you should be able to navigate through these models and see whether it matches with the existing business rules in that scenario, right? And then probably you have to put some test data and see whether we can generate some specific information the management requires. For example, we can have kind of a questions like, can we answer these questions? Which student had the best assignment one in INF, say 10004 in this semester? Or who is the convener when the student 1, 2, 3, 4, 5, 6, 7 was enrolled in INF? Can I actually find the answers for these by going through this model? So these are the bits and pieces you need to think before you model any problem. So this is really complex. I know that, but unfortunately you need to practice. Okay, so this is what I'm going to teach you in this semester. How are you going to create this kind of model? So if you know the patterns, now you can see the some of the patterns that we have studied here. Exactly same as the patterns that we actually learn in our this case study, this one, right? So some patterns are quite similar, right? So if you know the patterns, you can easily identify or construct a model without having any problem. All right, guys, is it clear? Is it clear for you guys? Can you give me a feedback? Is it clear? I know that it's a bit complicated. So far up to here, does it make any at least some sense? Let me. Can you tell me? Yeah. So far so good, Liam. Thank you. How about June, Kunjal, Mugesh, Kwok, Charmin, Shenal, Sia, Vanessa, Sue. Okay. Little yeah, I know that it take little time for you to get head around, so don't worry, but just read this one and then listen to my recorded lecture again, and then you will practice it. Yeah, one is a little bit, yes, okay, I need to watch recording, yes, Kunjala, yeah. So just watch them. So the idea that I'm trying to give here is always separate the static information with the variable information, right? But there has to have a logic when you separate it. And then learn the patterns that we have learned in these lectures. So then you can apply these patterns. Now remember the pattern. Last week we have done 2 case studies, right? Remember the pizza delivery system and then Glenferrie toy library. So in these two scenarios, we learned some patterns. Now here we have learned another pattern, right? How to distinguish variable and fixed information, right? So likewise, we will learn so those sort of patterns so you can apply. Right, so that is about the entity relationship diagram, ERD models. So let's now come back again for SQL stuff, right? Now let's forget about the ERDs. Let's come to our favorite SQL stuff again for temporary, so we can have kind of a relax mode. All right, now we are coming to the views, right? Now, sometimes there are some queries are so complex, right? Sometimes we, without writing the same query again and again, we may actually store a particular query in a variable, and then we can give a name for that particular query, right? So these are called the views, right? So view is a kind of way to store a complex query or the select command and give it a name. Okay, so that is what we mean by the view. For example, we may have a query like this. So select employee number, employee name, department. So you can see now different columns are coming from different tables, right? Actually, there are two tables. We use the inner join. And then I want this query to save as a view, right? So we can give a name for that view as emp view, okay? And then what I can do is if I save this query in a query view called emp view or variable called emp view, I can actually use this name to execute another SQL command. For example, if I write SQL command, write select asterisk from emp view, what it will do is it extract the SQL select command which we have recorded under the emp view and execute it, right? So that's very easy actually. Uh, so why we use the views? There are different reasons for use the views. There are so many advantages. View actually view in the database terms um, is actually we treat it as a virtual table, right? It's a virtual table. It looks like a table, it behaves like a table, but actually it's not a table, but it's simply a block of SQL codes that we store. The main reason for that is for the simplicity purposes, because if you have very complex query which link maybe 10 or 15 tables, sometimes without rewriting it we can use the view. And the other important advantage is sometimes we don't want every user to see which columns we are actually referring in this particular query, because it's so sensitive, some of the columns in some tables. So if we want to hide some information from the user's perspective, we can use a view. We create a view and we'll give the view to them. Okay, you play with that view, that's it, right? So they can't see what's coming on. I don't know what kind of tables come with but all what they know is, okay, these are the columns I have to play with. Okay. And one of the important thing that you need to remember is the rows that generate by the views. For example, if I run the view, if you generate the rows, right, it will not going to save anywhere, right? So each time when the view is referenced and view is called, the SQL code in the view is executed. That's about the view. Okay. But the thing that you need to remember is view actually behaves like a table. Even sometimes you can insert rows using the views as well, right? Or even you can modify the rows using the views as well. Um, and we can even join it with the where clause, even we can join it with the other tables, etc., etc. So that's very powerful actually, views in the databases. For example, now these are the things we can do. Example, we can just simply use another SQL query and use the view to grab the information. For example, here I'm running select asterisk from emp view, right? So what it will do is it just simply execute. It will take the emp view and it will display all the rows in the emp view query. That is what it does. And then the second example, I use where condition, right? So it will actually displays employee names. And now remember, in my view, which I have created here, has four columns: emp number, emp name, department ID, and department name. So in this case, I only want to display the information regarding the employee number 15, right? So I can use the where clause to limit that limit the extraction of information. And then the third one, here in the third one, I am actually using another inner join. I am actually combining the existing view with another table called the department table, right? I can do that as well if I use the view. So you remember in the now see the employee view. These are the columns I am considering, right? So department ID is one of the columns it coming from the employee table, right? So if I have the department ID in that view, I can actually now link with that department ID with another table called department table with the department ID in that as well, because looks like these two information is same. So I can link it with the inner join. So that's perfectly okay. So basically we use views for the simplicity purposes, right? Because sometimes, for example, think about in a company, we need to use multiple tables, right? There are some users like power users, like what they do is they just wanted to, they use Excel spreadsheets. They suck some information from different tables and then they play with Excel to create some models, multiple models, and then they make decisions based on this model. So in that case, what we can do is we can create some views for them, because we don't want them to mess up with our database, right? So we create different views, and then we can give these views to themselves, and they suck information from these views to Excel or Tableau, whatever the report generators they use. So usually the most of the well-designed databases, right, even when you go to the industry, you will see majority of the databases that we design, we need to actually design the views as well, because there can be multiple users for multiple purposes. For example, if you're we can create a kind of a view. For example, we can create a view called sales view, right? So sales view can have four tables with different queries. For example, we can have 4 different tables in that sales view, maybe a couple of joins with one outer join or couple of another outer joins with where, close, ands, and rows grouped by having, etc. So if you create all these stuff inside the view, nobody can see what's actually going on inside. They know is when they use it, they know what are the information they receive, then they can actually play with it, right? So it's very easy for end users. So how are you going to create a view? This is how you're going to create a view. This is the command: create view, and then we'll give a name, right? Whatever the name, and then use the as keyword, and then we just write the query, right? So in this case, you can see it's a complex query, right? So we have an aggregate function as well. So select department name, average salary from the employee, and then inner join, right? And then group by department name, and having close, having average salary greater than or equal to 50,000. Right, so the users will simply run the select statement, select asterisk from empower, so this will execute, right? So remember, the views will not going to save any information, right? So if I ask a question, if you think about these 3 tables, right, employee, department, and the region, and if I created a kind of a view like this, for example, create view E view, and I am just simply write a select statement which use these 3 tables and 3 columns coming from these different 3 tables, name coming from employee table, department name coming from the department table, region name coming from the region name table, right? And then if I ask a question like how many rows are stored in the view after executing this SQL query, so my answer is 0 rows, right? Remember, views will not going to record any rows. What it does is it just execute this command and extract information and display the information in your screen. So it will not going to record anything. Okay, so that is what you need to remember. But remember, there is a way that we can actually record the information using a view as well, but we are not going to teach you in this semester. So more often we use views for security reasons, because for example, if you think about, think about a Swinburne, right? So Swinburne, we may have a table called employee table. That employee table can have some general information as well as some private information, right? So we don't want everybody to access our employee table. So we can put some access restrictions, right? For example, for that reason, I can actually create three types of views, right? For example, I can have a view for a general employee. So everybody in the company can actually see all the staff numbers, staff name, office number, phone number, etc., etc., right? And then I can have another group of people called the management group, right? They can actually queried only the columns like, okay, what are the salary column, or annual leave column, or the home phone column, etc. So these considered as a very sensitive information, right? And then another group of people in my people and culture team, right, or the payroll team. So they can actually have a kind of another kind of access, right? Like they can modify or update salary details, annual leave details, etc., etc. Okay, so likewise, then in a company we can have three types of roles, right? General roles, management role, and the payroll role, right? So that means we can actually, how can we allocate these different roles to different access levels? What we can do is we can create three types of views, right? Three types of views. This is how it happens in normally in practice, because we have several access rights, right? So several table we can't. So as a student, you can't access some table, right? As a staff, we can have access right to some table, but we don't have access right to other tables, right? So how we do it? By creating different views actually. So for example, I can have a view called emp everyone view. Okay, I can have emp manager view or emp payroll view, right? So emp everyone view means anybody in this. So anybody can access these four columns in my employee table. So emp manager view means everything else in this green part plus salary, annual leave, and home phone, right? And payroll view means I believe that everything in this table, right? Then what we can do is we can allocate the users for each of these views, and we can give access rights. So we can deny read and write access to employee table, right? Anyone who is employee all user view, or anyone employee anyone view, can have only read access for the selected columns, right? So anybody who is an employee manager will have only read access to the certain columns, right? And then employee payroll view, people who are assigned there have a read and write access, because remember we should be able to provide some updates to annual leave and salary for the payroll paper, so they have the write access as well. Right, so this is how we give the read-only access, right? We can just give a phase like with read-only. So when you create the view, right? So we write the create view statement like create view emp view as, right? So we just write, okay, these are the columns we are going to select from the employee table, and then we say, okay, with read-only. So that means they are not able to write anything. Remember that I told you, if you through the views, from using the views, people can actually update some information. Yes, because views behaves like a table, right? If you select certain columns, right? If you don't use the read-only command, anybody can actually update those columns using the view, right? So we don't want that to happen. So therefore, we give this condition saying with read-only, right? If so, therefore, if someone trying to delete something like okay, delete from emp view, then they will get a kind of an error message saying cannot perform DML operation on read-only. Okay? So this is how actually we restrict the users to access some information. Yeah, as I mentioned before, it is possible as to insert rows to tables using view or update rows in the table using view as well. But you need to be extremely careful when you do that, right? The reason is when you're trying to insert an update, a table can have some constraint. Remember the constraint that we implement in certain columns in tables when you write the create table statement, right? So we need to be very careful. Sometimes when we create the views, that view may not contain the columns that we created, the constraints in the original table, right? The classic example is, say, for example, in this case, I am having a table or student table or create table statement in the student table. I have implemented a constraint in the gender column, right? Remember the check constraint, gender check constraint, it has to be in one of these values, right? And then, now what do you mean by this check constraint? Check constraint means the gender column must contain one of these values, right? Must contain one of these values. So if I create a kind of a view saying, okay, create a view student view or STU view, I select in student ID, student name, only two columns from this table, right? And then if I try to insert something using this view, right, insert into student view, student ID, student name 100, Sue Davis, now I'm getting an error message. Why? Because the reason is this view does not contain the gender column, which is very absolutely important because we have implemented a constraint on the gender column, right? So if I insert something which is not considered the gender column, then I'm getting an error message, right? So therefore, it's very tricky. Implementing or using the views are very tricky. You need to be think about lots of other things before you create views, right? Um, and then the same thing will happen sometimes if you have some kind of other constraints implemented in your tables as well. So you need to be extremely careful. But we are not going. I'm not going to actually test how to. What I want you from this level is how to create a view. That's all. I'm not actually going to test what will happen. This constraint break, etc. Because this is something too much for you guys. Okay. So if you're really interested in specializing in database or data analytics or data management streams, of course, you need to learn these kind of things. Okay, so it's a bit tricky. So that's yeah, right. So that is my final slide. That's actually conclude our lecture discussion today.